Hello, friend. Welcome. If you're hearing these words, then you've found your way here, to this quiet space, and I'm so glad you did. Wherever you are right now, whatever brought you to this moment, I want you to know that you can let go. You can settle in, get comfortable, adjust your pillow, pull your blanket a little closer, let your shoulders drop away from your ears, soften your jaw, and if you'd like, you can close your eyes. There's nothing you need to do right now except listen and breathe and rest. Because tonight, we're going to explore something extraordinary, something you carry with you always, something so familiar you might have stopped noticing how miraculous it truly is. We're going to talk about your body, not in a clinical way, not with big complicated terms or frightening facts. No, we're going to talk about your body the way you might talk about the ocean, or the stars, or a forest at dawn, with wonder, with gentleness, with quiet awe. Your body is a universe, a soft, breathing, living universe. And while you rest here, while you let the day fall away, that universe continues its ancient work, caring for you in ways you'll never have to think about. So, take a breath, a slow one, and let's begin. While you rest here, while your thoughts begin to drift and soften, something extraordinary continues inside you. Right now, in this very moment, your brain is working. Not in the way it worked today during your meetings or your errands or your worries. No, right now, it's working in a different way, a deeper way. Your brain, that soft 3-pound universe cradled inside your skull, is doing something remarkable. It's consuming energy, so much energy. Even though it only makes up about 2% of your body's weight, your brain uses 20% of all the energy you take in. 1/5 of everything you eat, every bit of oxygen you breathe, goes to fuel this quiet miracle between your ears. And right now, as you rest, as you let go, your brain isn't slowing down. In some ways, it's more active now than it was when you were checking your phone or driving your car or making dinner. Because your brain is made of 86 billion neurons, 86 billion tiny cells, each one connected to thousands of others, creating a web so complex, so intricate, that we're still discovering how it all works. These neurons, they talk to each other. They whisper across tiny spaces, using electricity and chemicals, sending messages faster than you can imagine. And right now, even now, they're firing in patterns, in waves, like a slow ocean tide moving through your mind. When you sleep, when you truly let yourself rest, your brain enters different stages. It cycles through them every 90 minutes or so, moving from light sleep down into the deep places, then back up again. And in those deep places, something beautiful happens. Your neurons fire together in synchronized waves. They pulse like a heartbeat, like a drum, and as they do, they're working. They're taking all the things you learned today, all the moments you lived, and they're sorting through them, deciding what to keep, what to remember, what to let go. This is how memories form. Not all at once, but slowly, gently during these quiet hours when you're not trying to remember anything at all. Your brain is a caretaker. It works while you sleep, consolidating your experiences, strengthening the connections that matter, pruning away the ones that don't. And sometimes, in the lighter stages of sleep, your brain creates dreams. Those strange, impossible stories that feel so real while they're happening. Dreams are your neurons playing, experimenting, mixing memories and emotions and images into something entirely new. Scientists still aren't completely sure why we dream, But maybe that's okay. Maybe some mysteries are meant to stay soft around the edges. What we do know is that your brain never stops caring for you. Even now, it's monitoring your breathing, your heart rate, the temperature of your body. It's keeping you safe, keeping you alive. And it does this without asking for applause, without needing your attention. Your mind is always working, always holding you, even in the deepest sleep. So rest now. Let your brain do what it knows how to do. You don't have to help. You don't have to try. Just breathe and trust and let yourself drift. And while your brain orchestrates thought, while it tends to the garden of your consciousness, something else continues its ancient rhythm. Listen closely. Be very still. There it is. Can you feel it? Your heartbeat. That gentle drum, that endless pulse, that quiet companion that's been with you since before you were born. Your heart is beating right now. It's been beating all day, all night, every moment of your entire life, and it will keep beating faithfully until your very last moment. This is not a metaphor. This is not poetry. This is fact, and it's staggering when you really stop to think about it. Your heart beats about 100,000 times every single day. 100,000 contractions, 100,000 moments of pushing blood through your body, of keeping you alive. And over the course of a day, your heart pumps about 2,000 gallons of blood. 2,000 gallons, circulating endlessly through the vast network of vessels that wind through every part of you. Your heart is a muscle, but it's unlike any other muscle in your body. It never gets to rest the way your arms or legs do. It never stops, never pauses, never takes a break. And yet, it doesn't wear out the way you might expect. Your heart has its own electrical system, a natural pacemaker that generates the rhythm, that keeps the beat going without any conscious thought from you. In fact, your heart is so independent, so self-sufficient, that if you removed it from your body and gave it oxygen and nutrients, it would keep beating on its own. It has everything it needs built right into its tissue. The cells of your heart decided, long ago in your development, to specialize completely. They committed themselves to this one task, this endless work of contraction and release, and they stopped dividing. The heart cells you have now are mostly the ones you've always had. They can't regenerate the way other cells can. And so your heart, this faithful servant, this tireless companion, makes do with what it has. It strengthens itself, adapts itself, but it cannot replace itself, which makes its dedication even more profound. Your heart knows it gets only one chance, and it uses that chance to keep you alive every single day without fail. And here's something tender. During sleep, your heart rate slows. It drops down, settling into a gentler rhythm, giving itself the closest thing it ever gets to rest. Your heart works a little less hard when you sleep, and maybe that's one of the reasons sleep feels so restorative. You're not just resting your mind, you're giving your heart a softer night, a quieter few hours. There's something else too, something that scientists are only beginning to understand. Your heart doesn't just pump blood, it communicates. It sends signals to your brain through the nervous system, and these signals can affect your emotions, your perceptions, your sense of well-being. When people talk about the heart as the seat of emotion, they're not entirely wrong. Your heart and your brain are in constant conversation, and the rhythm of your heart can actually influence the way you feel. When your heart beats in a smooth, coherent pattern, your mind tends to feel calmer, more balanced. And right now, as you rest, As you breathe slowly and deeply, your heart is likely settling into one of those smooth rhythms. It's finding its ease. So take a breath, a slow, deep breath, and feel, if you can, that steady presence in your chest. That drum that's never missed a beat for you. That heart that's kept you alive through every moment of your life. The joyful ones and the hard ones, the moments you remember and the ones you've forgotten. Your heart has been there for all of it. And it's here now, beating softly, keeping time, holding you in this moment. You are alive, and your heart is the proof. That blood your heart pumps, that endless river moving through you, it carries something precious. Oxygen. Every moment of every day you're exchanging worlds. Right now, without thinking, without trying, you're breathing. Air flows into your nose or your mouth, travels down your throat and enters your lungs. And in your lungs, something extraordinary happens. Your lungs aren't just empty sacs. They're intricate, branching structures like trees turned inside out. The air travels through your trachea, then splits into 2 bronchi, one for each lung, and then those bronchi split again and again, branching into smaller and smaller tubes, until finally the air reaches tiny little grape-like sacs called alveoli. You have about 300 million alveoli in your lungs. 300 million tiny, delicate bubbles where the magic happens. The walls of these alveoli are incredibly thin, just 1 cell thick, and they're surrounded by equally tiny blood vessels called capillaries. And here, in this intimate meeting place, oxygen from the air you breathe passes through the walls of the alveoli and into your blood. At the same time, carbon dioxide, the waste product from your cells, passes out of your blood and into the alveoli, ready to be exhaled. This exchange happens constantly, effortlessly, with every single breath you take. If you could somehow spread out all those alveoli, flatten them into a single surface, they would cover an area about the size of a tennis court. Your lungs contain a tennis court worth of surface area, all folded and packed neatly inside your chest. And every breath you take, all that surface area is working, absorbing oxygen, releasing carbon dioxide, keeping you alive. You breathe about 20,000 times a day. 20,000 exchanges between your body and the world. And you don't have to remember to do it. You don't have to set an alarm or make a list or try hard. Your body knows. Your brainstem, that ancient part of your brain, monitors the carbon dioxide levels in your blood and adjusts your breathing automatically. When you need more oxygen, you breathe deeper, faster. When you're at rest, like now, your breathing slows, becomes gentler. And your nose, often overlooked, is doing important work too. It filters the air, trapping dust and particles in the tiny hairs and mucus. It warms the air so that by the time it reaches your lungs, it's close to body temperature. It humidifies the air, adding moisture so your delicate lung tissue doesn't dry out. Your nose is a sophisticated piece of equipment, preparing every breath for your lungs. There's a beautiful synchronization happening inside you. Your breathing and your heartbeat, they're not independent. They influence each other. When you breathe in, your heart rate tends to increase slightly. When you breathe out, it slows down a bit. This is called respiratory sinus arrhythmia, and it's a sign of a healthy, flexible nervous system. Your body is constantly making tiny adjustments, keeping everything in balance. And right now, as you rest, as you breathe slowly and deeply, you're helping your body find that balance. You're giving it space to regulate, to calm, to heal. When you exhale, You're not just releasing carbon dioxide. You're releasing heat, moisture. You're letting go of tension held in your chest, in your shoulders. Every exhale is a tiny surrender, a small letting go, and the world receives it. The air around you receives your breath, and in turn, you receive the air. And this exchange, this giving and receiving, connects you to everything. The oxygen you're breathing right now was produced by plants, by trees, by the algae in the ocean. You're breathing in the work of photosynthesis, the ancient process that transforms sunlight into life. And when you exhale, plants take in that carbon dioxide and use it to grow. You are part of a cycle. You are not separate from the world. Every breath is proof. You are woven into the fabric of life on this planet, connected to the trees and the oceans and every other breathing thing. So breathe now, slowly, deeply, and know that you are exactly where you belong. And beneath your breath, beneath the soft rhythm of your lungs, there is something else, something solid, something strong. You carry a skeleton, and it's easy to think of bones as static, as lifeless structures. But the truth is, your bones are more alive than you might imagine. You have 206 bones in your body, if you're an adult. When you were born, you had about 270, but as you grew, some of those bones fused together, becoming the skeleton you have now. And that skeleton is not just a frame. It's not just scaffolding holding you up. Your bones are living tissue, constantly changing, constantly rebuilding themselves. Every 10 years or so, you have an almost entirely new skeleton. Your bones are always breaking down old tissue and building new tissue, remodeling themselves in response to the stresses you place on them. If you exercise, if you walk or run or lift things, your bones respond by becoming denser, stronger. If you stop moving, they become more fragile. Your bones are listening to your life. Inside your bones, in the soft marrow at their core, something vital is happening. Your bone marrow is a factory producing blood cells. Red blood cells, which carry oxygen. White blood cells, which defend you against illness. Platelets, which help your blood clot when you're injured. All of these cells are born in the quiet center of your bones. Your skeleton is not just holding you up. It's creating the very substance that keeps you alive. And your bones are strong. Remarkably strong. The femur, the long bone in your thigh, is one of the strongest bones in your body. It's stronger than concrete, pound for pound. It can support 30 times your body weight without breaking. And yet, bones are also light. They're hollow in places, filled with air or marrow, so you can move without carrying too much weight. Your skeleton is an engineering marvel, balancing strength and lightness in perfect proportion. There's something poetic about bones, too. They last longer than almost any other part of you. Long after soft tissue has returned to the earth, bones remain. They hold the story of a life, the evidence of where you walked, what you did, how you moved through the world. But while you're alive, while you're here, your bones are doing something even more interesting. They're releasing hormones. Scientists have discovered that bones produce a hormone called osteocalcin, and this hormone affects your brain, your memory, even your mood. Your bones are talking to your mind. They're part of the conversation happening inside you, part of the network that keeps you balanced and well. And speaking of small things, the smallest bone in your body is the stapes, tucked away in your middle ear. It's about the size of a grain of rice, but it plays a crucial role in your ability to hear, vibrating in response to sound waves and passing those vibrations deeper into your ear. Even the smallest parts of you are essential. So rest now and know that beneath your skin, beneath your muscles, you carry an architecture that is constantly renewing itself. You are always rebuilding, always becoming new. Your bones know how to heal when they break. They know how to strengthen when challenged, and they ask for very little in return. Just movement, just nourishment, just time. Your skeleton is patient. It's been with you since the beginning, and it will carry you until the end. You are held always by this living framework. You are supported even when you feel like you're falling apart. Your bones remember how to be strong. Around those bones, wrapping them in layers of strength and softness, you have muscles. Over 600 of them, making up about 40% of your body's weight. Right now, even as you rest, hundreds of muscles are gently holding you. They're keeping you in position, whether you're lying down or sitting, making tiny adjustments to keep you comfortable and balanced. Muscles are extraordinary. They're made of fibers that can contract and release, pulling on your bones to create movement. When you decide to pick up a cup or walk across a room or smile at someone you love, your brain sends signals to your muscles and they respond instantly. But muscles don't just move you. They also generate heat, keeping your body warm. When you shiver, that's your muscles contracting rapidly to produce warmth. And when you exercise, when you use your muscles, they actually tear slightly at the microscopic level. This sounds harmful, but it's not. It's how muscles grow stronger. During rest, especially during sleep, your body repairs those tiny tears, building the muscle back a little bit stronger than before. This is why rest is so important. This is why sleep matters. Your muscles need these quiet hours to heal, to grow, to prepare for tomorrow. The strongest muscle in your body, in terms of the force it can exert, is the masseter. It's the muscle in your jaw that lets you chew. It can exert an enormous amount of pressure, up to 200 pounds on your molars. You use this muscle every time you eat, and it works tirelessly, day after day, breaking down food so your body can extract the nutrients it needs. And then there are the muscles in your eyes. These tiny muscles are some of the most active in your entire body. Your eyes move about 100,000 times every single day. Every time you read, every time you look around a room, every time you track movement or focus on a face, your eye muscles are working. And they do this with incredible precision, allowing you to see the world in sharp detail. There's something called muscle memory, and while it's not technically memory stored in the muscles themselves, it is real. When you practice a movement over and over, whether it's playing an instrument or shooting a basketball or typing on a keyboard, your brain and cerebellum create efficient pathways for that movement. Eventually, you can do it without thinking. Your body remembers. This is the gift of practice, of repetition. Your body learns. Most of the muscles you're aware of are skeletal muscles, the ones you can control voluntarily. But there's another type of muscle working inside you, muscles you never have to think about. Smooth muscle. These muscles line your blood vessels, your digestive tract, your bladder. They work automatically, controlled by your autonomic nervous system, contracting and releasing to move blood, to move food through your intestines, to manage all the processes that keep you alive. You don't have to tell your stomach to digest. You don't have to remind your blood vessels to adjust their diameter. Your smooth muscles handle it all. And right now, as you rest, your muscles are letting go. The tension you carried today in your shoulders, in your neck, in your jaw, it's slowly releasing. Your muscles know how to relax when you give them permission. They know how to soften, so let them. Let your shoulders drop. Let your face go slack. Let your hands unfold. You don't have to hold on to anything right now. Your muscles will hold you. They always have. And they'll be ready when you need them again. But for now, for this moment, they're resting too. And that's exactly what they need. Wrapped around all of this, around your muscles and bones and organs, is your skin, the largest organ you have, the one you can touch. Your skin is a boundary, a gentle border between you and the world, but it's also a connection. It's where you meet everything outside yourself. Your skin weighs about 8 pounds and covers roughly 22 square feet. It's your first defense against injury, against infection, against the elements, and it's always changing. Right now, in this moment, your skin is shedding. You lose about 30 to 40,000 dead skin cells every single minute. Every minute. These cells flake off so quietly you never notice, and new cells rise from below to take their place. Your skin renews itself completely about every 28 days. You are always new, always fresh, always becoming. Your skin is not just a barrier, it's an organ of sensation. It contains millions of nerve endings, tiny receptors that detect touch, pressure, temperature, and pain. When someone hugs you, when you feel the warmth of sunlight on your face, when you touch something soft or rough or cold, it's your skin that tells you. Your skin is how you feel the world. It's your direct connection to everything outside yourself. And your skin is smart. It knows how to regulate your temperature. When you're hot, the blood vessels in your skin dilate, bringing more blood to the surface where heat can escape. Your sweat glands open up, releasing moisture that evaporates and cools you down. When you're cold, those blood vessels constrict, keeping warm blood deeper in your body where your vital organs are. You might get goosebumps, a vestigial response from when humans had more body hair. Those goosebumps would fluff up the hair, trapping a layer of warm air close to the skin. We don't have enough hair for that to work anymore, but your skin still tries. It's doing its best to keep you comfortable. Your skin produces vitamin D when exposed to sunlight. It takes ultraviolet rays and converts a type of cholesterol in your skin cells into vitamin D, which your body needs for bone health, immune function, and so much more. Your skin is a factory, a sensor, a protector, all at once. And then there are your fingerprints, those unique whorls and loops at the tips of your fingers. They formed while you were still in the womb, as you moved and touched the walls of the amniotic sac. The patterns are determined by your genes and also by random factors, by the exact way you moved, the exact moment those ridges formed. No one else has fingerprints exactly like yours, not even identical twins. You are marked by your uniqueness from the very beginning. Your skin holds your story. Scars, freckles, lines. Every mark is a moment, a memory written on your body. And your skin is forgiving. It heals. When you're cut, your skin immediately begins to close the wound, sending cells to the area, forming new tissue, knitting itself back together. You carry your own repair kit, built into every layer. So rest now, and know that you are always shedding what you don't need, always making room for the new. Your skin understands impermanence. It understands renewal. And it keeps you safe, keeps you whole, keeps you connected to the world, one touch at a time. Beneath the surface, deeper inside, there's a whole world you rarely think about. An ecosystem, a garden. Right now, inside your digestive system, life is happening. Your digestive tract is about 30 feet long, winding from your mouth down to the other end. And along that journey, food is transformed. It's broken down, sorted, absorbed, transformed into the energy and building blocks your body needs. This process starts in your mouth, where your teeth grind food into smaller pieces, and your saliva begins to break down carbohydrates. Your saliva contains enzymes, special proteins that start the chemical breakdown of food before you even swallow. Amylase is one of these enzymes, and it begins breaking down starches into simpler sugars right there in your mouth. This is why if you chew a piece of bread long enough, it starts to taste slightly sweet. The starches are being converted to sugars. And when you do swallow, that's a complex coordination of muscles. Your tongue pushes food to the back of your throat. A flap called the epiglottis closes over your windpipe to prevent choking, and the food moves into your esophagus. Your esophagus is a muscular tube about 10 inches long, and it contracts in waves, a motion called peristalsis, pushing food downward toward your stomach. You don't have to think about any of this. You swallow, and your body takes over, guiding food on its journey. Interestingly, peristalsis is so effective that you could swallow while upside down, and food would still reach your stomach. Gravity helps, but it's not necessary. Your muscles do the work. Then the food reaches your stomach, and this is where things get serious. Your stomach is a muscular J-shaped bag located in the upper left part of your abdomen, capable of expanding to hold about 1.5 liters of food and liquid. And it's a harsh environment. Your stomach produces hydrochloric acid, one of the strongest acids in nature. The pH of stomach acid can be as low as 1 or 2, which is incredibly acidic. To put that in perspective, battery acid has a pH of 0, and pure water has a pH of 7. Your stomach acid is closer to battery acid than to water. This acid is so powerful it could burn through wood, dissolve metal, damage your skin if you touched it. Its job is to break down the proteins in your food, to kill any harmful bacteria or viruses that might have come along for the ride, and to create an environment where digestive enzymes can work effectively. The acid is produced by millions of specialized cells in your stomach lining called parietal cells. These cells pump hydrogen ions into your stomach, creating that intensely acidic environment. But here's the thing. If your stomach acid is strong enough to dissolve metal, why doesn't it dissolve your stomach? The answer is that your stomach has a defense system. The same cells that produce acid also produce a thick layer of mucus that coats the stomach lining. This mucus is alkaline, which neutralizes acid, and it forms a protective barrier between the acid and the stomach wall. Additionally, the cells of your stomach lining are tightly packed together, preventing acid from seeping between them. And these cells are replaced frequently. The entire lining of your stomach is replaced about every 3 to 5 days. Your body is constantly rebuilding this crucial barrier, making sure you're protected. If this system breaks down, if the mucus layer is compromised, or acid production becomes excessive, you can develop ulcers, painful sores in the stomach lining. But under normal circumstances, your stomach is incredibly good at protecting itself while doing its dangerous, necessary work. Your stomach also churns. It has 3 layers of muscle that contract in coordinated waves, mixing the food with acid and enzymes until it becomes a thick, semi-liquid substance called chyme. This process can take several hours depending on what you've eaten. Carbohydrates are broken down relatively quickly in about 2 to 3 hours. Proteins take longer, around 3 to 4 hours. Fats take the longest, sometimes 6 hours or more. Your stomach is patient, thorough, making sure everything is properly processed before sending it on. And when the chyme is ready, a muscular valve at the bottom of your stomach called the pyloric sphincter opens, allowing small amounts of chyme to pass into the first section of your small intestine. This happens gradually, in pulses, ensuring that your small intestine isn't overwhelmed and has time to work on each batch of food. From your stomach, the chyme moves into your small intestine, and this is where most of the real magic happens. Your small intestine is called small, not because it's short, it's actually about 20 feet long, but because it's narrow, only about an inch in diameter. It's coiled up neatly in your abdomen, taking up a surprisingly small amount of space considering its length. The small intestine is divided into 3 sections. The duodenum, which is the first foot or so, is where chyme from the stomach arrives and where most of the chemical digestion happens. The jejunum, which makes up about the next 8 feet, is where most nutrient absorption occurs. And the ileum, the final 10 to 12 feet, continues absorbing nutrients and also absorbs vitamin B12 and bile salts. When chyme enters the duodenum, it's very acidic from the stomach. But the duodenum needs to neutralize that acid so the digestive enzymes can work. Your pancreas, a large gland tucked behind your stomach, produces bicarbonate, an alkaline substance, and secretes it into the duodenum. This bicarbonate neutralizes the acid, raising the pH to a more neutral level. At the same time, your pancreas secretes a cocktail of digestive enzymes. Proteases to break down proteins, amylase to break down carbohydrates, and lipase to break down fats. Your liver also contributes to digestion by producing bile. Bile is a greenish-yellow fluid that's stored and concentrated in your gallbladder, a small pouch attached to your liver. When you eat fatty foods, your gallbladder contracts and releases bile into the duodenum. Bile doesn't contain enzymes. Instead, it contains bile salts, which emulsify fats. Emulsification is the process of breaking large fat globules into tiny droplets, increasing the surface area so that lipase enzymes can break them down more efficiently. Think of it like dish soap, breaking up grease on a plate. Bile salts do the same thing to dietary fats, making them accessible to digestive enzymes. Without bile, you couldn't properly digest or absorb fats, and you'd be deficient in fat-soluble vitamins like A, D, E, and K. As the chyme moves through your small intestine, propelled by peristalsis, it passes over the inner lining, and this is where absorption happens. The lining of your small intestine is not smooth. It's covered with millions of tiny, finger-like projections called villi. Each villus is about a millimeter tall, and they're packed closely together like the pile of a carpet. And each villus is covered with even tinier projections called microvilli, which form what's called the brush border. If you could flatten out all this surface area, all the villi and microvilli, it would cover about 200 to 300 square meters, roughly the size of a tennis court or a basketball court, depending on how you measure. All that surface area exists for one purpose: absorption. As chyme flows past the villi, nutrients are absorbed through the walls and into the bloodstream. Amino acids from proteins, simple sugars from carbohydrates, fatty acids and glycerol from fats, vitamins, minerals, all of it passes through the intestinal wall and into tiny blood vessels and lymphatic vessels inside each villus. This nutrient-rich blood is carried first to your liver, which acts as a processing center, deciding what to store, what to convert, what to release back into circulation. And then there's your microbiome. You are not alone in your digestive system. You carry trillions of microorganisms, mostly bacteria, living primarily in your large intestine, but also throughout your digestive tract. These aren't invaders or infections. They're partners, symbionts. You have about 100 trillion bacterial cells in your gut, and they outnumber your own human cells. In fact, you're more bacteria than human, at least in terms of cell count. These bacteria weigh about 2 to 6 pounds in total, roughly the weight of your brain. And they're incredibly diverse. You have hundreds of different species of bacteria in your gut, each with its own role, its own niche. Some bacteria help you digest fiber, breaking down plant materials that your own enzymes can't touch. Humans don't produce cellulose, the enzyme needed to break down cellulose, the main component of plant cell walls. But some gut bacteria do, and they ferment this fiber, producing short-chain fatty acids that your colon cells use for energy. Other gut bacteria produce vitamins. Some species synthesize vitamin K, which is essential for blood clotting. Others produce B vitamins, including folate, biotin, and B12. Your gut bacteria are essentially a vitamin factory supplementing your diet. They also train your immune system. Your gut is where about 70% of your immune system resides, and it's constantly interacting with your gut bacteria. This interaction helps your immune system learn to distinguish between harmless microbes and dangerous pathogens. Babies born via C-section who don't pass through the birth canal and aren't exposed to their mother's vaginal and fecal bacteria often have different microbiomes and higher rates of allergies and autoimmune conditions. The early colonization of the gut is crucial for proper immune development. And your gut bacteria produce neurotransmitters. They produce serotonin, dopamine, GABA, and other chemicals that affect your mood and mental state. In fact, about 90% of your body's serotonin is produced in your gut, not in your brain. This serotonin doesn't cross the blood-brain barrier, so it doesn't directly affect your brain, but it does influence gut function and sends signals through the vagus nerve, which connects your gut to your brain. This is the gut-brain axis, a two-way communication system. Your brain can affect your gut, which is why stress can cause stomach aches or diarrhea. And your gut can affect your brain, which is why gut health is increasingly linked to mental health. People with depression, anxiety, and other mental health conditions often have different gut microbiomes than healthy individuals. The relationship is complex and not fully understood, but it's clear that your gut and your brain are in constant conversation. Your large intestine, also called the colon, is about 5 feet long and wider than your small intestine, hence the name. By the time material reaches your colon, most nutrients have been extracted. The colon's main job is to absorb water and electrolytes, concentrating the waste. It also houses the densest population of bacteria in your body. These bacteria continue working on any remaining material, fermenting fiber, producing vitamins, and contributing to the formation of stool. The waste moves slowly through your colon, becoming more solid as water is absorbed. Eventually, it reaches your rectum, where it's stored until you're ready to eliminate it. The entire journey, from the moment you take a bite of food to the moment waste leaves your body, can take anywhere from 1 to 3 days, depending on many factors including what you ate, how much fiber you consumed, your hydration level, and your individual physiology. And all of this continues even while you sleep. Your digestive system doesn't stop when you close your eyes. It keeps working, keeps processing, keeps extracting nourishment. Right now, if you've eaten today, your digestive system is still at work, quietly, efficiently, turning food into you. Your body knows how to take what it needs and let go of what it doesn't. There's a wisdom in that, a lesson maybe. You don't have to hold on to everything. You don't have to process everything forever. Take what nourishes you, extract the good, and release the rest. Your body does this naturally, without struggle, without overthinking. Maybe you can learn from it. Maybe you can trust just a little bit more that your body knows what it's doing. Because it does. It really does. So let it work. Let it digest, absorb, eliminate. Let it care for you from the inside out. You are a world within a world, and that world is thriving, flourishing in the quiet darkness of your body. And filtering it all, standing guard, working tirelessly in the shadows, are organs that most people never think about until something goes wrong. Your kidneys and your liver. These are your quiet guardians, your protectors, your purifiers, working every moment of every day to keep you clean, balanced, and alive. Let's start with your kidneys. You have 2 of them, bean-shaped organs about the size of your fist, each about 4 to 5 inches long. They're tucked against the back of your abdomen, one on each side of your spine, just below your ribcage. And what they do is nothing short of miraculous. Every single day, your kidneys filter about 50 gallons of blood. 50 gallons. To put that in perspective, your body only contains about 1.5 gallons of blood total. That means your kidneys are filtering your entire blood supply roughly 30 to 40 times every single day. They're constantly cleaning you, removing waste products, excess water, toxins, anything your body doesn't need, or that could be harmful. They do this by passing your blood through millions of microscopic filtering units called nephrons. Each kidney contains about 1 million nephrons, and each nephron is a tiny, intricate structure, a marvel of biological engineering. A nephron consists of a filter called a glomerulus and a long, twisted tube called a tubule. Blood enters the glomerulus under pressure. The glomerulus is a tight ball of capillaries, tiny blood vessels with walls thin enough to allow water and small molecules to pass through, while keeping blood cells and larger proteins in the bloodstream. This filtered fluid, now called filtrate, contains water, electrolytes like sodium and potassium, glucose, amino acids, and waste products like urea and creatinine. The filtrate then travels through the tubule, which is about 30 to 40 millimeters long if you could uncoil it, and along this journey, your body makes decisions. The tubule is lined with specialized cells that can actively transport substances either back into the bloodstream or out of the bloodstream into the filtrate. Useful substances like glucose, amino acids, and most of the water are reabsorbed back into the bloodstream. About 99% of the filtrate is reabsorbed. Only about 1% becomes urine. Your kidneys are incredibly efficient, conserving what you need and discarding what you don't. Waste products like urea, creatinine, and excess ions continue through the tubule and eventually collect in the renal pelvis, a funnel-shaped structure in the center of each kidney. From there, urine flows down the ureters, tubes that connect your kidneys to your bladder, where it's stored until you're ready to urinate. But your kidneys don't just remove waste. They're also master regulators. They balance your body's chemistry with remarkable precision. They regulate the levels of sodium, potassium, calcium, phosphate, and other electrolytes in your blood. Too much sodium? Your kidneys remove it in your urine. Too little? They conserve it, reabsorbing nearly all of it back into your blood. The same goes for water. If you're dehydrated, your kidneys hold onto water, producing concentrated dark-colored urine. If you've had a lot to drink, they release the excess, producing dilute, light-colored urine. This is regulated by a hormone called antidiuretic hormone, or ADH, which is produced by your brain and signals your kidneys to conserve or release water. Your kidneys are constantly adjusting, constantly fine-tuning, keeping your internal environment stable no matter what's happening outside. They also regulate your blood pressure. They do this in two ways. First, by controlling blood volume. More water in your blood means more volume, which means higher pressure. Less water means lower pressure. Second, by producing a hormone called renin. When your blood pressure drops, your kidneys release renin, which triggers a cascade of events that ultimately causes your blood vessels to constrict and your body to retain sodium and water, raising your blood pressure back to normal. This is called the renin-angiotensin-aldosterone system, and it's one of the most important blood pressure regulation mechanisms in your body. Your kidneys are constantly monitoring pressure and making adjustments. They also produce hormones beyond renin. They produce erythropoietin, often abbreviated as EPO, which stimulates your bone marrow to make red blood cells. When your kidneys detect low oxygen levels in the blood, they release APO, which travels to your bone marrow and tells it to ramp up red blood cell production. This is why people with kidney disease often become anemic. Their kidneys aren't producing enough EPO. Athletes sometimes abuse synthetic EPO to boost their red blood cell count and improve endurance, though this is dangerous and banned in most sports. Your kidneys are monitoring your oxygen levels and adjusting your blood production accordingly. Your kidneys also activate vitamin D. You might know that your skin produces vitamin D when exposed to sunlight, but that vitamin D is not in its most active form. It needs to be converted first by your liver and then by your kidneys into calcitriol, the active form that your body can use to absorb calcium and maintain strong bones. Without properly functioning kidneys, you can't activate vitamin D, which leads to weak bones and other problems. Your kidneys are essential for skeletal health, even though they're nowhere near your bones. And your kidneys work especially hard while you sleep. During the night, they're busy filtering, concentrating, producing urine that accumulates in your bladder. This is why you often need to urinate when you wake up. Your kidneys have been working all night, cleaning you, preparing you for the day ahead. They ask for very little, just adequate hydration, just reasonable care. Avoid excessive amounts of certain painkillers which can damage kidney tissue. Avoid extremely high protein diets which can strain them. And in return, your kidneys give you purity. They give you balance. They give you life. Without your kidneys, waste would accumulate in your blood, electrolytes would become dangerously imbalanced, and you'd die within days. Your kidneys are that essential, so thank them quietly for their endless work. And then there's your liver. Your liver is the largest internal organ you have, weighing about 3 pounds, roughly the weight of your brain. It sits on the right side of your abdomen, just beneath your rib cage, protected by your lower ribs. It's a dark reddish-brown color, soft and spongy to the touch, divided into 4 lobes, and it performs over 500 different functions. 500. It's almost impossible to overstate how important your liver is. It's a processing plant, a detoxification center, a storage warehouse, a manufacturing facility, all rolled into one. Let's start with detoxification, perhaps the liver's most famous function. Everything you ingest, whether food, drink, medication, or even things you absorb through your skin or breathe into your lungs, eventually makes its way to your liver. After your small intestine absorbs nutrients, that nutrient-rich blood doesn't go straight into general circulation. Instead, it goes through the hepatic portal vein directly to your liver. Your liver acts as a gatekeeper, inspecting everything that comes through. Your liver has specialized cells called hepatocytes, and these cells contain enzymes that can break down and transform substances. This is particularly important for toxins and drugs. Alcohol, for example, is broken down by liver enzymes into acetaldehyde, a toxic substance, which is then further broken down into acetate, which is harmless and can be eliminated. Medications are metabolized by liver enzymes into forms that your kidneys can excrete. Environmental toxins, pesticides, preservatives, anything potentially harmful, your liver works to neutralize. It does this using 2 phases of detoxification. Phase 1 uses a group of enzymes called cytochrome P450 enzymes to modify toxins, often making them more reactive. Phase 2 then attaches other molecules to these modified toxins, making them water-soluble so they can be excreted in urine or bile. Your liver is a sophisticated chemical laboratory, running countless reactions every second to keep you safe. But your liver can be overwhelmed. Chronic alcohol consumption, for example, damages hepatocytes faster than they can regenerate. The liver tries to repair itself, but excessive damage leads to scarring, called fibrosis. If the scarring continues, it becomes cirrhosis, where the liver is so scarred it can no longer function properly. Certain medications, if taken in excess or for prolonged periods, can also damage the liver. Acetaminophen, a common pain reliever, is safe in normal doses, but can cause severe liver damage in overdose. This is why it's important to be mindful of what you put into your body. Your liver is resilient, but it's not invincible. Your liver also produces bile. Every day, your liver produces about a quart of bile, a greenish-yellow fluid that's essential for fat digestion. Bile contains bile salts, which emulsify fats in your small intestine, breaking them into tiny droplets so digestive enzymes can work on them. Bile also contains waste products that your liver is eliminating, including bilirubin, a breakdown product of old red blood cells. Bilirubin gives bile its color and eventually gives your stool its characteristic brown color. If your liver isn't functioning properly, or if bile flow is blocked, bilirubin can build up in your blood, causing jaundice, a yellowing of the skin and eyes. But under normal circumstances, your liver produces bile continuously. Between meals, bile is stored and concentrated in your gallbladder. When you eat fatty foods, your gallbladder contracts and releases bile into your duodenum, helping you digest those fats. Your liver is also your body's main regulator of blood sugar. After you eat, glucose floods into your bloodstream. Your pancreas releases insulin, and insulin signals your liver to take up glucose and store it as glycogen. Glycogen is a branched polymer of glucose molecules, a storage form of sugar. Your liver can store about 100 grams of glycogen, and your muscles can store about 500 grams. When your blood sugar drops between meals or during exercise, your pancreas releases glucagon, and glucagon signals your liver to break down glycogen and release glucose back into your bloodstream. This keeps your blood sugar stable, preventing it from dropping too low. If you haven't eaten for a while and your glycogen stores are depleted, your liver can even make new glucose from non-carbohydrate sources like amino acids and glycerol, a process called gluconeogenesis. Your liver is constantly monitoring and adjusting, making sure your brain and other tissues have the steady supply of energy they need. Your liver produces proteins, lots of them. It produces albumin, the most abundant protein in your blood plasma. Albumin helps maintain blood volume and pressure by keeping fluid in your blood vessels rather than leaking into tissues. It also transports hormones, fatty acids, and other molecules through your bloodstream. Your liver produces clotting factors, proteins that allow your blood to form clots when you're injured. There are more than a dozen clotting factors, and most of them are made in the liver. People with severe liver disease often have bleeding problems because they can't produce enough clotting factors. Your liver also produces proteins involved in immune function, proteins that transport cholesterol and fats, proteins that bind and transport metals like iron and copper. It's a protein factory, constantly synthesizing what your body needs. Your liver stores vitamins and minerals. It stores iron, which is recycled from old red blood cells and used to make new ones. It stores vitamin A, which you need for vision, immune function, and skin health. It stores vitamin D, vitamin B12, vitamin K, copper, and glycogen. Your liver is a warehouse, keeping reserves on hand for when your body needs them. When you haven't eaten for a while, your liver releases stored glucose. When you're deficient in iron, your liver releases stored iron. It's constantly managing your body's reserves. Your liver also breaks down old red blood cells. Red blood cells only live about 4 months, and when they die, they're removed from circulation, usually by your spleen or liver. Your liver breaks them down, recycling the iron and converting the rest into bilirubin, which is excreted in bile. Everything is recycled. Nothing is wasted. Your liver metabolizes hormones. It breaks down excess estrogen, testosterone, thyroid hormone, cortisol, insulin, and many others, keeping your hormonal balance in check. Too much of any hormone can cause problems, so your liver ensures that excess hormones are degraded and eliminated. This is particularly important for thyroid hormone and sex hormones. Your liver converts ammonia into urea. Ammonia is a toxic byproduct of protein metabolism. When your cells break down amino acids, they produce ammonia, which is harmful to your nervous system. Your liver takes this ammonia and converts it into urea, a much less toxic substance that your kidneys can safely filter out and excrete in urine. This is called the urea cycle, and it's essential for survival. People with liver failure can develop high ammonia levels, leading to confusion, coma, and death. Your liver synthesizes cholesterol. Cholesterol has a bad reputation, but it's actually essential for life. It's a component of cell membranes, giving them structure and fluidity. It's the precursor for steroid hormones like estrogen, testosterone, and cortisol. It's used to make bile acids. Your liver produces about 80% of the cholesterol in your body. The rest comes from your diet. Your liver carefully regulates cholesterol levels, producing more when you need it and less when you have enough. It also packages cholesterol into lipoproteins, particles that transport cholesterol and fats through your bloodstream. You've probably heard of HDL and LDL cholesterol. These are types of lipoproteins. LDL, often called bad cholesterol, carries cholesterol from your liver to your tissues. HDL, often called good cholesterol, carries excess cholesterol back to your liver for disposal. Your liver is the central hub of cholesterol metabolism. And here's something extraordinary. Your liver can regenerate. If part of your liver is damaged or surgically removed, the remaining tissue can grow back. This isn't regeneration in the sense that a new liver grows from the old one. Rather, the remaining liver cells divide and enlarge, increasing the mass until the liver reaches its original size. You could lose 75% of your liver, and given enough time, usually a few months, it would restore itself to full size and function. This is almost unique in the human body. Most organs can't do this. Your heart can't regenerate if part of it dies from a heart attack. Your kidneys have limited regenerative capacity, but your liver, your remarkable liver, remembers how to grow, how to heal, how to restore itself. This regenerative capacity has limits, of course. Chronic damage, like that caused by long-term alcohol abuse, chronic hepatitis, or non-alcoholic fatty liver disease, can overwhelm the liver's ability to heal, leading to permanent scarring and cirrhosis. But under normal circumstances, your liver is remarkably durable, remarkably capable of recovery. Both your kidneys and your liver work hardest while you sleep. While you rest, while you let go of the day, they're working overtime, filtering, processing, detoxifying, preparing you for tomorrow. They're removing the waste products of the day's activities, the byproducts of energy production, the remnants of everything you ate and drank and breathed and absorbed. They're resetting your internal chemistry, bringing everything back into balance. Your liver is breaking down toxins, metabolizing hormones, producing proteins. Your kidneys are filtering blood, balancing electrolytes, concentrating urine. You are constantly being renewed, constantly being purified, constantly being cared for from the inside out. You don't have to do anything. You don't have to manage it or control it or even think about it. Your body knows. It's been doing this since you were born, and it will continue until your last day. You are held. You are tended. You are always being made new. All of this, all these organs and processes are connected by something flowing, something warm and vital and alive. Your blood. Right now, as you rest here, about 5 liters of blood are moving through your body. 5 liters, a little more than a gallon. It might not sound like much, but it's exactly what you need. And that blood is traveling an incredible distance every day. Your body contains about 60,000 miles of blood vessels. 60,000 miles. That's more than twice the circumference of the Earth. Arteries, veins, and capillaries weaving through every part of you, reaching every cell, every tissue, every organ. Your blood makes a complete circuit through this vast network about once every minute. Your heart pumps and your blood moves. It flows away from your heart through arteries, thick-walled muscular vessels that can withstand high pressure. It reaches your organs and tissues, delivering oxygen and nutrients, and then it flows back through veins, thinner-walled vessels with valves that prevent backflow, returning to your heart and lungs to be refreshed, reoxygenated, and sent out again. This cycle never stops. Your blood is always moving, always working, always carrying out its essential tasks. Your blood is not just a simple fluid. It's a complex tissue made up of several different types of cells suspended in a liquid called plasma. Let's start with the most abundant cells, the red blood cells, also called erythrocytes. You have about 25 trillion red blood cells in your body. That's trillion with a T. 25 million. Each one is shaped like a disc, slightly concave on both sides, which gives it a large surface area relative to its volume. This shape is perfect for what red blood cells do, which is carry oxygen. Each red blood cell is packed with a protein called hemoglobin, about 270 million hemoglobin molecules per cell. Hemoglobin is what makes your blood red. It contains iron, and when iron binds to oxygen, it turns bright red. When it releases oxygen, it turns darker, more bluish red. This is why arterial blood, the blood leaving your heart and traveling to your tissues, is bright red. It's loaded with oxygen. Venous blood, the blood returning to your heart, is darker because it's given up its oxygen and picked up carbon dioxide. Hemoglobin is a remarkable molecule. It's made of 4 protein chains, each wrapped around an iron-containing group called a heme. Each heme can bind 1 oxygen molecule, so each hemoglobin molecule can carry 4 oxygen molecules. In your lungs, where oxygen is plentiful, hemoglobin binds oxygen eagerly. But when it reaches tissues that need oxygen, where oxygen concentration is low, hemoglobin releases it just as readily. This property, called cooperative binding, makes hemoglobin an incredibly efficient oxygen transporter. And hemoglobin doesn't just carry oxygen. It also carries carbon dioxide, a waste product of cellular metabolism. About 20% of carbon dioxide is carried by hemoglobin. The rest is dissolved in blood plasma or converted to bicarbonate ions. When your blood reaches your lungs, hemoglobin releases the carbon dioxide, which you exhale, and picks up fresh oxygen, which you inhale. This exchange is happening with every breath, with every heartbeat, continuously, effortlessly. Each red blood cell lives about 120 days, 4 months. During that time, it makes thousands of trips through your circulatory system, traveling through your heart, your lungs, out to your fingers and toes, and every point in between, back again. After 4 months, the red blood cell is worn out. Its membrane is damaged, its enzymes are depleted. It can no longer do its job effectively. And so it's removed from circulation, typically by your spleen or liver, which have specialized cells that recognize old or damaged red blood cells and engulf them. The red blood cell is broken down. The iron is saved and sent back to your bone marrow, where it's incorporated into new red blood cells. The rest of the hemoglobin is processed into bilirubin, which your liver excretes in bile. Nothing is wasted. Everything is recycled. And your bone marrow is constantly producing new red blood cells to replace the old ones. About 2 million new red blood cells every single second. 2 million every second. You are constantly being renewed, cell by cell, moment by moment. Then there are your white blood cells, also called leukocytes. You have far fewer of these than red blood cells, maybe 1 white blood cell for every 600 to 1,000 red blood cells. But they're no less important. White blood cells are your immune system, your defenders, your protectors. They patrol your bloodstream and your tissues, constantly on guard, looking for anything that doesn't belong. Bacteria, viruses, fungi, parasites, even your own cells if they've become cancerous or damaged. White blood cells are remarkably diverse. There are several different types, each with its own specialty, its own role in defending you. Neutrophils are the most abundant type of white blood cell, making up about 60 to 70% of all white blood cells. They're like your first responders. When you get an infection, when bacteria invade, neutrophils rush to the site. They're fast, mobile, and deadly to bacteria. Neutrophils engulf bacteria in a process called phagocytosis, literally cell eating. They surround the bacterium, fold their membrane around it, and pull it inside, trapping it in a little bubble called a phagosome. Then they dump toxic chemicals into the phagosome, killing and digesting the bacterium. Each neutrophil can engulf and destroy multiple bacteria before it dies. When you have an infection, your bone marrow produces more neutrophils, which is why your white blood cell count goes up when you're sick. If you've ever had blood work done and been told your white count is elevated, it usually means your neutrophils have increased in response to an infection. Lymphocytes are another major type of white blood cell, and they're responsible for your adaptive immune system. This is the part of your immune system that learns, that remembers, that gets better at fighting infections over time. There are two main types of lymphocytes: B cells and T cells. B lymphocytes, or B cells, produce antibodies. Antibodies are specialized proteins, Y-shaped molecules that bind to specific targets, usually proteins on the surface of bacteria or viruses. When a B cell encounters a pathogen, it produces antibodies that specifically recognize that pathogen. These antibodies attach to the pathogen, marking it for destruction by other immune cells. They can also neutralize the pathogen directly, preventing it from infecting cells. And here's the remarkable part. Once a B cell has encountered a particular pathogen and produced antibodies against it, some of those B cells become memory cells. These memory cells stick around for years, sometimes for life. If that same pathogen shows up again, your memory B cells recognize it immediately and mount a rapid, powerful response, producing antibodies much faster than the first time. This is how immunity works. This is how vaccines work. You expose your immune system to a harmless version of a pathogen. Your B cells learn to recognize it, and if the real thing ever shows up, you're ready. T lymphocytes, or T cells, have several roles. Some T cells, called helper T cells, coordinate the immune response. They're like generals directing the troops. They activate B cells, telling them to produce antibodies. They activate other immune cells, telling them to attack. Without helper T cells, your immune system would be disorganized and ineffective. This is why HIV is so devastating. HIV infects and kills helper T cells, crippling the immune system and leaving you vulnerable to infections you'd normally fight off easily. Other T cells, called cytotoxic T cells, directly kill infected cells or cancer cells. They recognize cells that have been compromised and destroy them before they can cause more harm. And like B cells, T cells can form memory cells, providing long-lasting immunity. There are other types of white blood cells too. Monocytes, which circulate in your blood and move into tissues where they become macrophages. Large cells that engulf pathogens and debris. Eosinophils, which fight parasites and play a role in allergic reactions. Basophils, which release histamine during allergic reactions and help fight parasites. Your immune system is incredibly complex, incredibly sophisticated, with multiple layers of defense, multiple types of cells, all working together to keep you safe. And all of this is happening right now, even as you rest. Your white blood cells are patrolling, watching, ready to respond if any threat appears. Then there are platelets, tiny cell fragments that help your blood clot. You have about 150,000 to 400,000 platelets per microliter of blood. In total, you have about 1.5 trillion platelets in your body at any given time. Platelets aren't really cells. They're fragments of larger cells called megakaryocytes, which live in your bone marrow. A single megakaryocyte can produce thousands of platelets. And these platelets are essential for hemostasis, the process of stopping bleeding. When a blood vessel is damaged, when you cut yourself or bruise yourself or injure yourself in any way, platelets rush to the site. They're activated by contact with exposed collagen, a protein in the blood vessel wall that's normally hidden but becomes exposed when the vessel is damaged. Activated platelets change shape, becoming spiky and sticky. They stick to the damaged tissue and to each other, forming a plug that covers the injury. This is called a platelet plug, and it's your body's immediate response to injury, a temporary patch. At the same time, platelets release chemicals that activate a cascade of clotting factors, proteins in your blood that work together in a complex series of reactions. This cascade ultimately produces fibrin, a stringy protein that forms a mesh over the platelet plug. The fibrin mesh traps blood cells and platelets, forming a solid clot that's much more stable than the initial platelet plug. This clot stops the bleeding and gives your body time to repair the damaged vessel. Eventually, once the vessel is healed, the clot is broken down and removed. Without platelets, even a minor injury could be life-threatening. You'd bleed and be unable to stop. But you have them, hundreds of billions of them, always ready, always vigilant. And then there's plasma, the liquid part of your blood. Plasma makes up about 55% of your blood volume. The other 45% is cells. Plasma is mostly water, about 90%, but it also contains hundreds of dissolved substances. It contains proteins like albumin, which helps maintain blood pressure and osmotic balance, preventing fluid from leaking out of your blood vessels into your tissues. It contains clotting factors, the proteins that work with platelets to stop bleeding. It contains antibodies, part of your immune system. It contains hormones, chemical messengers traveling from one part of your body to another, coordinating everything. Insulin from your pancreas, thyroid hormone from your thyroid gland, adrenaline from your adrenal glands. All of these travel through your bloodstream via plasma. It contains nutrients, glucose, amino acids, fatty acids, vitamins, minerals, all being delivered from your digestive system to wherever they're needed. It contains waste products, urea, creatinine, lactic acid, being carried to your kidneys and liver for elimination. It contains electrolytes, sodium, potassium, calcium, chloride, magnesium, bicarbonate, all essential for nerve function, muscle contraction, pH balance, and countless other processes. Plasma is the medium, the transportation system, the communication network, the supply chain, all in one. Your blood type is determined by proteins and sugars on the surface of your red blood cells. The most well-known blood type system is the ABO system, discovered in the early 1900s. If you have A antigens on your red blood cells, you're type A. If you have B antigens, you're type B. If you have both, you're type AB. If you have neither, you're type O. And then there's the Rh factor, another antigen. If you have it, you're Rh positive. If you don't, you're Rh negative. So you might be A positive, O negative, AB positive, and so on. These differences matter for blood transfusions and pregnancy. If you receive blood that doesn't match your type, your immune system might recognize the foreign antigens and attack the donated blood cells, causing a potentially life-threatening reaction. This is why blood is carefully typed and cross-matched before transfusions. During pregnancy, if the mother is Rh negative and the fetus is Rh positive, the mother's immune system might produce antibodies against the fetus's blood, causing problems. This is prevented with medication. But most of the time, your blood type is just a fact about you, a small part of what makes you unique. Your blood also carries heat, distributing warmth from your core to your extremities. Your body generates heat through metabolism, particularly in your muscles and organs. Blood carries this heat through your body, keeping your temperature relatively uniform. When you're cold, blood vessels in your skin constrict, reducing blood flow to the surface and keeping warm blood near your vital organs. This is why your fingers and toes get cold first. When you're hot, those vessels dilate, bringing blood to the surface where heat can escape through your skin. Your blood is part of your body's sophisticated temperature regulation system, constantly adjusting to keep you comfortable, to keep you alive. And your blood vessels, the tubes that carry your blood, are not just passive pipes. They're active, living tissue, constantly responding to your body's needs. The walls of your arteries are thick and muscular, capable of withstanding the high pressure generated by your heart. These muscular walls can contract and relax, narrowing or widening the vessel, controlling blood flow and blood pressure. When you exercise, your muscles need more blood, so the vessels supplying them dilate. When you're digesting food, vessels supplying your digestive system dilate. Your body constantly adjusts blood flow, prioritizing where it's needed most. The inner lining of your blood vessels, called the endothelium, is a single layer of cells, but it's incredibly active. It produces substances that regulate clotting, preventing clots from forming inappropriately, but allowing them when needed. It produces substances that regulate inflammation, keeping it in check. It produces substances that affect vascular tone, telling vessels to constrict or relax. Your endothelium is constantly communicating with your blood and with the rest of your body, maintaining balance. And the smallest vessels, the capillaries, are where all the real exchange happens. Capillaries are so small that red blood cells have to pass through them in single file, one at a time. The walls of capillaries are only one cell thick, allowing for easy diffusion of oxygen, nutrients, carbon dioxide, and waste between your blood and your tissues. Every cell in your body is within a short distance of a capillary, usually just a few cell widths away. This proximity is essential. Oxygen and nutrients need to reach every cell, and waste needs to be carried away. Capillaries make this possible. Your capillary beds are extensive, intricate networks that ensure every part of you is bathed in blood, nourished by it, sustained by it. You are a river, a warm, flowing river that never stops, a river that touches every part of you, from the top of your head to the tips of your toes. And that river carries life. It carries oxygen to fuel your cells, nutrients to build and repair them, hormones to coordinate them, immune cells to protect them. It carries away waste, carbon dioxide, toxins, anything that would harm you. It distributes heat, keeping you warm. It responds to injury, clotting to stop bleeding, then healing and moving on. Your blood is always working, always caring for you, always keeping you alive and right. Now, as you rest, as you breathe slowly and deeply, your blood is still flowing, still nourishing, still protecting. You don't have to think about it. You don't have to manage it. It just happens, automatically, perfectly, endlessly. You are held by this river. You are sustained by it. You are always connected to every part of yourself by this warm, flowing life. So here you are now, all these systems, all these processes, all working together in a harmony so intricate, so complex, it's almost beyond comprehension. You are trillions of cells, all cooperating, all communicating, all working toward the single goal of keeping you alive, of keeping you here, of letting you experience this world. You are atoms, elements forged in the hearts of dying stars billions of years ago, now arranged into this temporary, beautiful, improbable pattern called you. You are carbon and hydrogen, and oxygen and nitrogen, the building blocks of life. You are calcium and phosphorus, giving your bones strength. You are iron carrying oxygen in your blood. You are sodium and potassium, creating the electrical signals in your nerves. You are sulfur and magnesium and zinc and copper and selenium, trace elements that play essential roles. You are all the elements of the periodic table, combined in exactly the right proportions to create life, to create consciousness, to create you. You are water, mostly. About 60% of your body weight is water. You are a walking ocean carrying the memory of ancient seas inside you. Your blood is salty, similar in composition to seawater. Your cells are bathed in fluid that echoes the primordial oceans where life first began. You carry your origins with you, always. You are stardust, animated and aware. Every atom in your body, except for hydrogen, was created in a star. The lighter elements, like carbon and oxygen, were forged in the nuclear furnaces of stars like our sun. The heavier elements, like the iron in your blood and the calcium in your bones, were created in the violent explosions of supernova, massive stars dying in spectacular fashion. When those stars exploded, they scattered these elements across the universe. Eventually, those atoms found their way into a cloud of gas and dust that collapsed to form our solar system, our planet, and eventually you. You are made of the universe. You are not separate from it. You are part of it. You are the universe experiencing itself, becoming conscious, able to contemplate its own existence. And that is extraordinary, that is profound, that is almost miraculous. The odds of you being here, of all the atoms that make you up coming together in just this way, at just this time, in just this configuration, are vanishingly small. And yet, here you are, breathing, thinking, feeling, being. You exist. Against all odds, despite the vast improbability, you exist, and you are connected. Every breath connects you to the air, to the plants that produce oxygen, to every other breathing thing. Every bite of food connects you to the sun, whose light was captured by plants through photosynthesis. It connects you to the soil, to the rain, to the entire web of life on this planet. You are not an isolated individual. You are woven into the fabric of existence. You belong here, and you are temporary. This body, this collection of systems and cells and atoms, it won't last forever. Nothing does. Every cell in your body has a lifespan. Some live for days, some for weeks, some for months, some for years. Your red blood cells live 4 months. The cells lining your stomach live about 5 days. Your skin cells live 2 to 3 weeks. Your liver cells can live years. Even your bones, which seem so permanent, are constantly being remodeled, broken down and rebuilt. You are always dying and being reborn in small ways every day. Most of you is replaced every 7 to 10 years. You are not the same person you were a decade ago, not physically anyway. Most of your atoms are different. You are a pattern, constantly refreshing itself, constantly renewing. And someday the process will stop. Your heart will beat its last beat. Your lungs will take their last breath. Your brain will fire its last thought. And all the atoms that make you up, all the elements you've borrowed from the universe, will return. They'll be released back into the world, to be used again in new forms, new patterns, new lives. You will become soil, and from that soil will grow plants. Those plants will feed animals. Those animals will breathe and move and eventually die, returning their atoms to the soil, continuing the cycle. You are not separate from this cycle. You never were. You are part of it, have always been part of it. And when your time comes to let go, you'll give everything back, returning to the universe that made you. There's something peaceful in that, don't you think? Something comforting. You don't have to hold on so tightly. You don't have to carry the weight of permanence. You are allowed to be here, fully, completely, for as long as you're here. And then you are allowed to let go, to release, to return to the great cycle of matter and energy that is the universe. But that's not now. Right now, you're here. You're alive. Your heart is beating, your blood is flowing, your breath is moving in and out, steady and sure. You are present in this world, occupying this body, experiencing this moment. And that is enough. You are enough. You don't have to be perfect. You don't have to be flawless or strong or beautiful by someone else's arbitrary standard. You just have to be. You just have to exist. And you are doing that right now beautifully. Your body is doing its best. It's always doing its best, even when it hurts, even when it's tired or sick or struggling or in pain. Your body is trying. It's trying to heal, to balance, to keep you going. It's fighting infections, repairing damage, maintaining equilibrium. It's doing all of this without complaint, without asking for recognition, without needing thanks. So maybe, just maybe, you can be a little gentler with it, a little kinder, a little more patient, a little more grateful, not in a forced way, not in a way that feels like an obligation or a chore, but just in a quiet acknowledgement, a soft thank you to the heart that keeps beating, to the lungs that keep breathing, to the cells that keep dividing and working and living, to the systems that keep functioning, keep coordinating, keep caring for you. You are being cared for every moment by your own body. It has never stopped caring for you. It has never given up on you, and it won't, not until the very end. So let yourself rest now. Let go of the day, of the worries, of the tension you've been carrying. Let your body do what it knows how to do. Let it breathe and beat and flow. Let it repair and restore and renew. You don't have to help. You don't have to manage it or control it or even understand it. Just let it be. Just let yourself be. You are held by your body. You are held by the earth beneath you, by gravity pulling you gently down. You are held by the universe itself, by the same forces that hold the planets in their orbits and the stars in the sky. You are part of something vast, something ancient, something that has been unfolding for billions of years. And you are safe. For this moment, at least, you are safe. So close your eyes if they're not closed already. Feel your breath moving in and out, slow and steady, like waves on a shore. Feel your heart beating in your chest, that faithful drum that has never missed a beat for you. Feel the weight of your body, solid and real, resting on the surface beneath you. You are here. You are real. You are alive. And as you drift, as you let yourself sink deeper into rest, into sleep, know that your body will keep working. It will keep caring for you. It doesn't need your permission or your attention. It just does it, automatically, perfectly. Your brain will cycle through its stages of sleep, moving from light sleep to deep sleep and back again, dreaming its strange dreams, consolidating your memories, clearing away the metabolic waste that accumulated during the day. Your heart will beat a little slower, giving itself some well-deserved rest. Your lungs will breathe, steady and sure, exchanging oxygen for carbon dioxide, keeping your blood fresh and oxygenated. Your bones will continue their slow, quiet work of remodeling, building new tissue, strengthening themselves. Your muscles will repair the tiny tears from the day's activities, growing stronger, preparing for tomorrow. Your skin will shed its dead cells and make new ones, renewing itself, always renewing. Your digestive system will process whatever you've eaten, extracting every bit of nourishment, eliminating what can't be used. Your liver and kidneys will filter your blood, removing toxins, balancing your chemistry, purifying you from the inside out. Your blood will flow endlessly, tirelessly, nourishing every cell, carrying away every waste product. Your immune system will patrol, watching for threats, destroying anything that might harm you. All of this will happen without you having to think about it, without you having to try, without you even knowing it's happening. Your body knows what to do. It has been doing this for as long as you've been alive, and it will keep doing it as long as you're here. So rest now, gentle soul. Rest deeply. Let yourself surrender to sleep, to the quiet, to the darkness. You are safe. You are cared for. You are always and forever held. And when you wake, whenever that is, whether in a few hours or in the morning, you'll be a little bit newer, a little bit more healed, a little bit more restored. Because that's what your body does. It heals, it renews, it repairs, it never stops, it never gives up on you. So don't give up on it. Be kind to it. Be gentle with it. Be grateful for it. Give it the rest it needs, the nourishment it asks for, the movement it craves, the care it deserves. And it will carry you through this life, strong and faithful and tireless, until your very last moment. You are a miracle, a walking, breathing, living miracle, a temporary arrangement of matter that somehow became aware, became conscious, became capable of love and wonder and curiosity and joy. And you are loved. Maybe not by everyone, maybe not in the way you want, but you are loved by your own body, which has never stopped working for you, never stopped protecting you, never stopped trying to keep you alive and well. You are loved by the universe, which gave you these atoms, this life, this moment. You are held. You are safe. You are exactly where you need to be. Sleep well, dear friend. Sleep deeply. And know that you are whole. You are enough. And you are more precious than you could ever imagine. Good night.